So yeah, so we are done with defining our material. You can notice that M20 is defined it. Okay, just now after that we will define our rebar also. We have defined our rebar also along with that. And also we'll just see that, okay, which sections it is assign it. It is a column, concrete column 1. So just I will change the material to that property. So I will just go to section property, frame section. I will just change this material which has been assigned it. I will give our section reinforcement also. Just we will change it. Okay. Was only there. And for beams also it was a concrete beam 1. Just I will go to define option, section, frame section, concrete beam 1. I'll modify it. Okay, just I will change this section also here. Okay, okay, software has assigned a T section here. Okay, you can see that. Okay, but we will give only the beam, that is normal beam only, like this. Okay, just I will name it M20. I will give here name also, that is beam, and rest I will let it be same only, and I will change the reinforcement. So what I will do, I will go to select option here, select object types. I will just select all the beams. I will assign this frame section property, and I will give the and beam property which I have defined it. Okay, and yeah, and along the slab also we have to see that what are the property which has been assigned to slabs. Okay, so slab 1, and also there is a column drop also. You can see this is the column drop. Okay, so that also we have to see once. Let's go to cell property. There will be, you will find a slab sections. So drop 1 again we have to change our, yeah, and also you know that this column drop, who will tell me what is the modeling type will be there? Column drop, I have explained you that there is different modeling type for column drop. When we are studying about modeling types, there is cell thin, cell thick. Not remember, Janice?
No, sir.
So you know that this column drop is critical in shear. Okay,
Yes.
so there will be cell thick because cell thick catches the deformation also, shear deformation also. Okay,
Okay.
that we have to keep it on a column drop. Okay, so you increase this size, it is for 50, keep it material M20. And remember this column drop which we are giving, actually we have to not give from the slab level. We have to give from top to column. You know what is the column drop? Anyone is confused about column drop? Yeah. Any dot with column drops? Just I will show you in the photo that will be more clear to you. Okay. So this is, we can say that this is a column drop. We can say that. Okay. This is also another drop panel also. Okay. So some of the photos you can watch it here, that is the column drops and all. Okay, here also you can see this. You will find it a column drop.
Hello, sir. But why do we use a column drop?
See, you know that we are not giving a beams in this flat slab. This structure was based on the flat slab. Okay, so flat. If you're not giving any beams to that, so this uh, there will be chance of failures. Okay, so column drop, will see in the columns nearby the column there will be lots of stresses. Okay, so to cancel the things we are going to give the column drop. Okay, because you know that
So,
there
and
will be not any beams. There will not be
and
any beams here.
okay, sir. And also we have to provide stud rail over there.
Yeah, yeah, that also. Okay, so you have to see column drop. So I have given the section size column drop 450. So 450, how, see, remember always one thing more we have to focus that, see, you know that this structure will calculate the depth of your uh, column drop from the slab level. Okay, so you don't think that this only the small part you're seeing, this portion is a small part which we are seeing. Okay, so this is the outside of their slab. So if you give the column drop, it will be the column slab depth plus this also. Okay, this will be more clear to this picture. So yeah, so suppose this is your slab thickness. Okay, so this is your slab thickness, and this is the drop panel. Okay, so what 450 is up to this position. We do not think that we have given 450 up to here only. This will not be 450. This is wrong. So complete here to here, this 450 will be there. Okay, so suppose if you want to give a drop of 200 mm, so 200 plus your slab thickness. Suppose that you have given slab thickness of 200, so it will be 400. So your how much column drop will be of 400, not a 200. That also one
Okay,
of the important things we have to keep it in our mind. Okay, so we are done with our column drops and we are left with the slabs. So we have a slab 1 here. So we have to modify the material property of slab 1. So define section. There will be slab section. Okay, so slab 1, you modify it and you change property. And this will leave it with Celthin only at 200. Okay, so I think we have done with our defining our section. Just we have to see that, okay, this is fixed or not. Yeah, it is already known that this is the fix and load. Okay, so load, just I will apply some general load to this structure. Okay, so just I will give a general load, that is a general load. So general load is what? The basics load, that is 1.5 and live 2. Okay, so just I will select object types. I will select our floors. So yeah, and remember this along with floor where drop is also selected. Okay, so I will go to select option, deselect, and you will find a property and you will find a slab sections here. Yeah, you have to deselect this. Okay, and then we have to assign it. There you will be finding cell load set. You have to give the general load, and yeah, and also you need to give the frame loads also. Just select your frames like beams. You have to go to frame loads. You give it 10. Run your analysis. Okay, just I will change the settings also. Everyone please watch it here. Always run with a multi-thread. Okay, so this will give you fast result. Save it. Okay, so yeah, so you can see that I have got a displacement of 20 mm. Okay, and yeah, and also we have to see in the load combination like add new combinations. Okay, you have to add live also along with that. Just I will make it as a service. So deform shapes combo. Okay. So how much it is? Maximum displacement, it is 32, 31, 33 and all. So that I know that, okay, displacement will come because there is no beams and all. Okay. So you know that thickness we need to increase and all. That is another case. I will just not talk about the any design perspective. I will just teach you about the construction sequence. What all things are there in construction sequence. So right now with the project which you are saying, what happened actually, we are applying every load at once. Okay, you can see that dead load, slab load, everything is applied it. Okay, but when the structure, real structure is going to made, it is not going to make like this. Real structure is made first floor, then after second floor, then after third floor, and then after fourth floor. So okay, so your what happened, your this time dependent property and also your loading will also change according to that. Okay, so how you can encounter these things and how you can be more practically about that thing. Okay, so you know that this procedure which I am telling you, it is not like it is not applicable. Every consultant, if you see the major MNC company and all, generally apply these applications. Okay, you don't think that okay, sir taught me that it is not used and all. It's not there. They are going to use it. This application are always it is going to use it in the industry. So just check it how you have to apply this. Unlock our model. First, we have to see the, you have to go to define options. Okay. And you will find the option of auto construction sequence and analysis. And here will be written case is in active. Okay. So there will you have to active this case. Okay. And after that, you have to select your geometrical nonlinearity. Okay. So geometrical nonlinearity option is like P delta, and also right now I will not consider any geometrical nonlinearity along with this analysis. So just I will keep it as a none only, and you will get a replace a dead load type with this load cases. It all this just I will give this value, and I will just keep it okay. What happened? I have not changed the dead also. Dead also I have keep it as a one only. You have seen this. So what happened? I have not changed the factor also. It was just a one only. Okay, so I will go to again define options. You will find the load cases. So this as auto construction load cases, you will find it here in the load cases. You have to modify this. Okay, so what is the stage name? Step number 1, step number 2, step number 3, stage number 4. This is a step like construction of first floor, construction of second, third, fourth. Okay, and this is the durations, like how much days duration is. Suppose this value from where you will get it. This value will get it from project manager. Okay. Okay, so what is the duration of first stage? What is the duration of this and all? Okay. Just give me 1 minute, please. Yeah, hello. Yeah, sorry. Okay. It's audible.
Yes, sir.
Hello. Yeah, yeah.
Yes.
So look at very carefully here. You will find it uh, a cases which was I have given you active. So these cases, when you will give active in the load cases, it will be seen like load cases of the sequence and all. And also we have defined the duration of days also. Okay. And see, right now, you know that the cases has been defined it. Okay. And there is options of giving a material property at time. Okay. I think, yeah. Okay. So just also mass source, we have to give it like, you know that there is a one mass source only that is, we have defined it already. Okay. And also there is a property of giving like P delta effect, again, same. Okay. Like if you want to consider the material properties and all, you will be there. Okay. So yeah, so like that you can define the construction sequence analysis, no issue. And also you know that this we have defined it. And see, always remember, see, if you're doing any creep analysis, suppose that I have done the construction sequence. Okay. See, I will let add a copy of it, and I will write it a creep. Okay, just I want to see the creep of 40 years. Okay, just I will write a years. Okay. So again, I will give the duration of days 20, 20, this also 20, this also 20. Okay. This also 20, and I will add 1 year, that is after 1 year. So it will be around 365 days. Again, I will add another year, that is after it will be around 40 years. So after 40 years, just have to multiply by 360 multiply by 40. So how much it will be? Who will give me answer? How much it will be? Multiply by 440 multiply by 360.
14400.
Just I will use this also. Just you can multiply with this. Okay. Just I've given 360 and 365 also. So this is the duration days. You have to go to stage operations here. You have to add the object. So after you can see that after 1 year, just you have to come with the stage 1. Okay, just check it once that every stage has been defined it. Yes, defined it. This is left. A stage 4 is left, and after 1 year left. So you add your structures. Okay, so yeah, is that just you have to see that live load we have to add it. Okay, so you will get the options of adding live load here only, load objects. Okay, so you add it live. Okay, so you know that every structures which is made after 1 year, you will not get a complete occupancy. You will get occupancy around 90% and all. So you have to add the 0.9 as a load objects here. Okay, so just again go to another. There you go to load objects. Okay, here you will find a live load after 40 years completely. Means that, see what happened actually in apartment is made, it takes around 1 year to complete adjust to every, see all the apartments, you know that it takes around 1 year 2 year after completion to completely full. Okay, so that according to that you have to give this value, just give it. Okay, and also after giving this, one of the most important thing, just keep it in our mind about the material properties again. So material properties, that material are time dependent, this we need to keep it. Okay, as let else is okay. So again go to here you will find the options known as define options. There you will find material properties here. Okay, select your material, that is M20, and you will get a time dependent property here. Okay, so this creep and shrinkage, this need to be keep it. Okay, and see this code, you know that I explained you that time also, the Indian code you will not find it here. Okay, so you know that Indian code, if it is not there, so you have to take it the help of this code, because in Indian code in this graph you will not find it here. CV code, there is Canadian code. Okay, just keep it. Okay, okay, if you want to change the value also, you can change it from here. Just keep it. Okay, okay, so we are done with our defining. Okay, so just I will analyze this file. Okay, and also a load combination, you will find it. So if you run the analysis, this date will automatically convert it into auto construction sequence. And also if you add your default load combination, in that you will find this. You know that nonlinear analysis, it may take time, but I think it is so fast. Creep also, it is running too fast. So yeah, so you have to go to 3D options here. Just I will add a new window here. Okay, so you know that this which we are saying, this is a displacement in date, and this did not consist of any creep, this window, but we are looking this window will this change to deformation shapes here, and I will just select the load cases creep here. Okay, and I will apply once. So right now you can see that this structure is showing your deformation on a stepwise. Okay, and also we have to see the right side here, you will get a minus 15 here. Okay, so again the come out to second level, so you will get a, so yeah, directly we are jumped to the 40 years here. So 40 here you can see that how much displacement it is minus at 320. You can see everyone. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So and also I think that, and also the dead and alive here you can see that it is very less. If you multiply with the directly, if you multiply with that also, you will get you will not get that value. Okay. So if you suppose I'm seeing this auto construction sequence, okay, with creep and all, okay, just I will go to the maximum value here. You apply it maximum. Maximum it is find some value here. Okay, you have to see absolute. Okay, just do not depend upon the maximum. We have to see the absolute maximum. Why we are seeing the absolute maximum? Because we do not want to take consideration of minus and plus. So you have absolute. So how much it is? It is 935 again. You can say this value 935. Okay, and absolute is, see, I have to see that, okay, where, how you can get the absolute value. You have to see from here you will get this value. Okay, and if you want to use the multi-step method, you can have a multi-step also, like first step, okay, second, third, fourth. Okay, so but fourth one you can see that it is a minus 40. Again we have a fifth step. Okay, that is I think it was 1 year, no, I think 1 year you will get this one displacement. Again if you see that 40 years, sorry, this 1 year was this, okay, and last was of 40 years. 40 years it is 935, so much high. Okay, so 935 displacement, do you think that, and if you follow our simple procedure, that is by the creep coefficient, then how much value will get it? Okay, for that just I have follow our simple procedure that I explained you, that you select your lot combination is go to user value. Okay, you apply it. So you just saw the default shape, service, use it, apply it. So how much it is? It is, I was saying in this, so we have to see here. Was it getting on here about 30, I think. Okay. So you can take any, yes, also, and also that I told you that please consider the virtual also. Okay. So if you see here, you're getting 935 around. No, why we're getting, okay. Always I'm taking this, okay, I'm just have to take here, then we have to see. So it is 33. So 33, and suppose that I have considered the creep coefficient 3. So how much it will be there? So 33 multiplied by 3, it will be 99 around. Okay. So that much difference is that between your correct analysis and the performing the nonlinear analysis. That one difference is that. Okay. So I think that it is clear that how you can define it, this construction sequence. Okay. And also, yeah, and also remember that this analysis which I am performing, it is actually you have to perform for the longer span, like I told you, like this project is a longer span, then you will get a valid result. Suppose that there is any structure which is not, we can say that much subjected to deflection. Okay, in that case, why need to perform? It is not needed only. Okay, so this construction sequence analysis generally performed at creep analysis for the longer span of your structures. Okay, for cantilever, which is very long, any structures like 30 feet, 40 feet, 50 feet span is that. Okay, so in that structure, we generally good to analyze that type. Okay, so this is also completed. So yeah, and also I will explain you more about this, many thing more when you will apply with your own. Okay, so first you try to apply that yourself, that how you see. First you try to see your creep, that your first method which I have explained yesterday. Then you apply this method. Okay, then that's everyone. I will see that how you're checking the result tomorrow. Okay, so when you will come tomorrow, I will just try to share everyone a screen, and I will see that how you're applying this effect. And you know that you can make prototype model like this also, and you can apply nothing else. You cannot take, if you're not completed with your that project. Okay, you can make a prototype model like this, and you can analyze this.